Hi, class. We have a couple more topics related to pointers to cover this week. And it's going to be these three right here, the member selection operator, um, how if we're using dynamic memory, we'll also need to destroy our objects as well as the memory references, the pointers. Um, and then kind of putting it all together, we'll talk about having a dynamic array of structs. So first, this member selection operator, that's going to be required anytime we're dealing with and passing pointers. And we're pointing or passing a pointer to some type of an object that is either going to be a class object or a union, if we remember those from our earlier coding experiences, or a struct. So all three of those entities there can contain private member information. And we remember, like with structs, we used to access the member elements through the dot operator. So we could go like the struct name dot the attribute, and this would reference that attribute properly and return it. But we can't do this type of direct access when we have dynamic data structures that we don't have direct access to. So what we use instead is the member selection operator. That's just the arrow operator. And it's just a one-for-one substitution. Suppose we're sending in some kind of a list. Well, let me fix that on the iPad. So let's say that we've got a function, we're sending in a reference to a dynamic array. Well, since we are sending in that pointer, we can't use the direct syntax to access whatever that pointer's pointing at, their private member variables. We have to instead use the indirect syntax, which is the arrow operator. And it'd just be a one-to-one replacement, basically. We would here use, if we threw in, say, star nm as a pointer to some type of data type, well, then later on in our code, we could use just simply nm arrow, the attribute, to access that. So let's take a look at some code that is going to help that make a little more sense. All right, here we've got some sample code. This is just the students and test example that you'll see very commonly. It's a good way to, a good solution to try and create for the case where we've got multiple students and each student themselves has multiple objects related to whatever attribute they might have. In this case, tests. So we are going to first of all create a struct called student, and note what it's got in it. String, fine. Integer, fine. But then it has got a dynamic array of integers. Now note that inside this struct here, that's not where we allocate the new memory. We're going to allocate that further below, when we are creating our struct for the first time. We do that because we don't want to, we want to have the memory allocation occur at the proper place, and that's where the code is executed rather than where the code is just defined. And you'll see this also with object-oriented programming, that just a class definition by itself does not execute any code unless we have very specific code written in it to do some activity related to the instantiation of an object and then the destruction of an object when we no longer need it. So we've got an integer pointer here to grades, and let's take a look at what else we got. A couple of function prototypes here where we're going to send in a reference to a student. let's look at the main function. We simply create a student here and then create a pointer to that student. Now you're probably asking, why even do that? Why create a pointer here when we could just use the native student object, that struct? And it's because we're going to do this dynamically, and in just a little bit, we're going to take this and add complexity by making this a dynamic array itself of students. Right now, it's just simply a pointer to a single student. Then we call the two functions and just pass in the pointer. Let's look then at that flow. The pointer for input student then goes down here. So that reference name is now SPTR for student pointer. And because we are passing in a pointer, we'll have to make sure that we use the correct syntax for pointers. And this member selection operator, the arrow operator, is what we need. So let's take a look at those instances where we might need that. First, here we're going to, as our first task, get the name of the student. So we'll use that using getLine, but then where do we store it? Well, we received a pointer to a student already, so we can just assign that to the name attribute. And we will use the arrow pointer since this is a pointer to a student and not a student object. Same thing, when we input the ID here, we can just store that directly in the ID attribute. Now, let's take a look, though, at the grades. So that was where we are creating this array of grades. And in this case, I've got a constant set for 2 just for the number of grades, just to keep our testing short. But you'll see here, this is where we create a dynamic array. The new operator is creating a new array of this size formed of integers, and we are going to assign that to the pointer's grades attribute. So we've got that link made, and now we can just simply go through and get some input using cin, and every time, since we're inputting into an array now, then we can just input into the pointer object's grades attribute and the correct element indexed. Now, when we display the student, we have to do the same thing because we're sending in a pointer to a student. So that means anytime we want to access these attributes, we have got to use the member selection operator. So you'll see, just like above, we've got these instances of that member selection operator. All right, our next thing to discuss is a destructor for these struct objects that we're creating. And this destructor is actually going to have executable code. And whenever a struct goes out of scope and gets destroyed, normally the processor just takes care of it, just removes that memory allocation. But since our struct now itself contains a pointer to some dynamic memory somewhere, we need to make sure that we do the proper housekeeping to properly destroy that destructor. And of course, we can see the tasks there are going to be, let's delete the array, and then we need to redirect the pointer. Since the pointer itself is really never destroyed, we redirect it so it's pointing to the null pointer. So let's take a look at these two tasks then that a destructor is going to have to do within our definition of the struct. Here's that code that I'm adding to the struct definition, and this is the destructor right here. First, we're going to copy the struct name right here and put the little tilde character in front of it, and that signifies that this is the destructor code for this type of an object. And all we do is those two pieces of housekeeping that I just mentioned, since our struct has this dynamic array, we need to make sure that we destroy it before we destroy the struct. If we don't do this piece of housekeeping, well, that'll just result then in a memory leak. It means that this grades array has been allocated somewhere in our RAM, so it's occupying memory. And yet, if we destroy the struct, then we also destroy the pointer to that memory. And therefore, we can never reference that memory. So it's a memory leak. The only way it can go away is by program termination. So we don't want memory leaks. So we want to make sure to be a good citizen and do our due diligence with our memory and delete it. So that's what it does. And then this other line in line 14 is just a very good practice. When you delete a pointer, you're not actually deleting the pointer itself, you're deleting what it references or what it's pointing to. And in that case, rather than having a dangling pointer, since it was pointing over to this thing that got deleted, well, it's still pointing to that memory address. And now it's going to possibly point to junk or some unintended piece of data if the processor decides to store something else right there. So we do want to ground out the pointer and reassign it as the null pointer. And that just is pointing it to null. So this way, then when our code executes and we get to the spot where our student object is destroyed, which is going to be right here at the end of our program, well, we're guaranteed no memory leaks. Maybe there's some subsequent code or something that wouldn't be impacted. So hope this explains that. Let's take a look at our next thing to make up about pointers. Now, our third follow-up thing for pointers is creating this dynamic array of struct. Now, since we have a definition for a struct itself, the definition is above main, clearly we will want to create this dynamic array within our main function. Now, when we do this, we'll actually put it into a loop so we can create and populate the struct objects that are now a member of the array that we just created. So let's take a look at this code. Here's what we're doing with this code. So we've got the same student struct with its destructor. I'm now, since we're going to create this dynamic array in main, and it's going to be an array of these struct objects, then I've got a constant set here just for the number of students that we'll do. Again, since we're going to be dealing with a dynamic array, we do need to declare its size, and 3 will be our students. Each student then will have 2 grades. Now, to show what we're kind of going for here, let's do a quick run of the program, just so we can look then for those markers in our code. So we're going to just do the student grade scenario. I'm going to enter a name and an ID, and then we've got 2 tests per student. So I'll enter grade number 1 and grade number 2, and then that takes us now to student number 2. And then student number 3. Student number 3 is Jack, and he's not doing so well in his schooling, is he? And then we just get that data output showing that its entry into the data structure was successful, and then we could extract it for output. So let's look then at the code and how the code is now changed to support this dynamic array of students. So here in line 22 is the declaration. We're going to create this dynamic array called roster, and it's going to hold student objects, and it's going to hold 3 of them. Now, our code will do a couple of things in a for loop. Since we know a known number of iterations, 3 for 3 students, then we'll just run this 3 times, and we'll call that input student function each time. Now, this might look a little bit weird. Look at this. We're sending in a reference, and we still have, as an argument, a pointer to a student. So let's make sure we can reconcile that and understand what that is. The input student function here is expecting a pointer to a student. So let's take a look and see if that in fact is a pointer to a student. And roster sub I is in fact right here a pointer to a student. So we've got type matching, no mismatch, and we are going to send the correct piece of data then to that function. Now, it would error if we took that reference variable out, and you can see it's already starting to give us the indication of what the problem is. And let's see the run code here. And the problem here is that if we send roster sub I, that's an actual struct object. It's an actual student. So if we send that to the function is expecting a pointer to a student, but instead receives a student. And we've got a type mismatch there, and that's why we're drawing this error. So we need to send it a pointer to a student, and a pointer to a student is nothing more than the address of that student. So we can use the address operator, we send it, and now everything works just fine. Now, as a point of reference, Replit is outstanding when it comes to helping us troubleshoot. Here, you can see that I've got this issue, and maybe I don't know what the problem is, but it's got this red underline, it's starting to look angry, and if I run it, it's spitting out a whole bunch of text showing where the problem is. But it doesn't necessarily tell us how to fix it. So what I love about Replit is that if you hover over it and press the debug button, it'll actually pull up this little kind of a large language model AI and give you some very good instruction on what the error was and how to fix it. So here it tells us what the error was. It was a problem that we didn't send a pointer to a student, but instead sent a student. And it gives you an idea for what code to change. And yep, there's my reminder to put that reference operator back into roster sub I, and now it'll run just fine. So I encourage you to use this AI component of Replit. It's a great tutor and a great teacher. And it's perfectly within bounds for use in this course. All right, I hope that helps. Good luck on the assignments, and please hop into the discussion boards or to the Zoom Q&A sessions if you've got anything you want to ask. See you later.